In this video, let us learn about inverse Laplace transform solving using convolution theorem. Why to use convolution theorem? Sometimes the inverse Laplace transform of product of two functions cannot be found directly. The convolution theorem provides an alternative method to evaluate such inverse transforms. It converts the product of two Laplace transforms into an integral involving their inverse transforms, which will be easy for us to solve. Now let us see what is convolution theorem statement. If L inverse of f of s is denoted by f of t and L inverse of g of s is equal to g of t, then L inverse of f of s into g of s is equal to f of t star g of t. Or otherwise, L inverse of f of s into g of s is equal to L inverse of f of s star L inverse of g of s. So this integral is called the convolution of f of t and g of t. Simply the product f of s and g of s when used L inverse will be converted to convolution between two functions. Here f of t star g of t represents integral 0 to t f of u into g of t minus u into du. Now based on this convolution theorem of inverse Laplace transform, let us solve some examples. Let's go for the first problem. Using convolution theorem, let us solve L inverse of 1 divided by s into s square plus a square. So this problem can be actually solved by the partial fraction technique also. But now let us solve this problem using the convolution theorem. So now we can write this L inverse of 1 by s into s square plus a square as 1 by s into 1 by s square plus a square. So that means this, let us take it as f of s, and this term will be your g of s. So according to the convolution theorem statement, your L inverse of f of s into g of s will be equal to, it is L inverse of f of s star L inverse of g of s. So when using the statement, we will be having here, this is equal to L inverse of 1 of s star L inverse of 1 by a square plus a square. Now we know that what is L inverse of 1 by s? L inverse of 1 by s is 1. So this will be 1 star. So here L inverse of 1 by a square plus a square will be 1 by a into sin 80, or otherwise sin 80 divided by a. So now we can use the formula for the convolution between two functions. So we know that f of t star g of t will be equal to integral 0 to t f of u into g of t minus u into du. Now let us apply here. Here this function is going to be your f of t, and this second function is going to be a g of t. Okay, if you apply this one, we will be having, it is equal to integral 0 to t. So f of t is a constant function, so we will be having that as 1 itself. And the second function, the t will be replaced with t minus u. So by a is there, that 1 by a I am taking it outside. So it will be into sine of a into t minus u into du. Now we have to integrate this. We'll substitute the limits and we will directly get the solution for our given problem. So that is equal to 1 by a into, so your integration of sine of a into t minus u will be minus cos of a into t minus u divided by the coefficient of u will be minus a divided by minus a, and the limits will be from 0 to t. So this negative and negative will be getting cancelled. So I can take that a outside, it will become 1 by a square. Let us substitute the upper limit. If we substitute the upper limit, it will be cos of, it is t minus t. So we'll be getting 0 there. Then minus the lower limit is, when I substitute it for u, you'll be getting cos a into t minus 0. So this is nothing else. Cos 0 will be 1. So 1 by a square into 1 minus cos at. So this will be the solution of the problem. L inverse of 1 divided by s into a square plus a square is equal to 1 by a square into 1 minus cos at. Let us go for another problem. Let us evaluate L inverse of 1 divided by s plus a into s plus b. So this can be broken into L inverse of 1 by s plus a into 1 by s plus b. So let me again write the convolution theorem statement. It is L inverse of f of s into g of s will be equal to, it is L inverse of f of s star L inverse of g of s. Okay, so here this function is going to be your f of s, and this function, the second function is going to be a g of s. So let us now apply this statement. We will be having L inverse of 1 by s plus a and star L inverse of 1 by s plus b. Very well, we know what is L inverse of 1 by s plus a. It is going to be e to the power of minus at star, it is e to the power of minus bt. And again, we know that convolution, your f star g will be equal to integral 0 to t f of u into g of t minus u into du. Let us apply this one. So this function is going to be your f of t, and this function is going to be your g of t. When we apply this one, we'll be having integral 0 to t. Instead of u, we have to, instead of t, we have to replace it with an u. So we'll be having e to the power of minus au into g of, for the second function, we have to replace our t with t minus u. So it will be, second function will be, it is e to the power of minus b into t minus u into du. So now we will simplify this one and let us integrate it with respect to u, then substitute the limits 0 to t, we will be getting the desired solution. So now again I'm writing that function. It is integral 0 to t e to the power of minus au into e to the power of, I can break the term minus b into t minus us, e to the power of minus bt into e to the power of bu into du. So this is a constant since we are integrating with respect to u. So this can be written as e to the power of minus bt into integral 0 to t. So this can be written as e to the power of, if I take an u commonly outside from the first and the last term, it is b minus a into u into du. So if I substitute the limits, upper limit minus the lower limit, it is e to the power of minus bt. What is integration of e to the power of b minus a into u will be e to the power of b minus a into u divided by b minus a, and the limits are from 0 to t. So upper limit minus the lower limit will be having e power minus bt divided by b minus a. Upper limit will be t, if you substitute e to the power of b minus a into t, and the lower limit will be e to the power of 0, it will be 1. Now we can multiply this term inside. If you multiply inside, we'll be getting 1 by b minus a into e to the power of minus bt. This term can be broken into e power bt into e power minus at, and the second term will be minus e power minus bt. So the final answer will be 1 divided by b minus a into, so this term and this term will be getting cancelled. So e to the power of minus at minus e power minus pt. So this is the solution. Now let us go for another example. Let us solve one more problem. Using convolution theorem, let us solve L inverse of s divided by s square plus a square the whole square. So this can be written as L inverse of 1 divided by s square plus a square into s divided by s square plus a square, which is equal to, we can write this as L inverse of 1 by s square plus a square star L inverse of s divided by s square plus a square, by using the convolution theorem statement for Laplace transform. So what is L inverse of 1 by s square plus a square will be 1 by a into sine at star L inverse of s by s square plus a square will be cos at. Now let us apply the convolution between these two functions. We'll be having 1 by a into integral 0 to t. It will be sine au into cos of a into t minus u into du. So here let us use the sum and product formula. We know that 2 sine a cos b is equal to sine of a plus b plus sine of a minus b. So let us take au term as a and this a of t minus u term as b. So if we apply this formula, we'll be having 1, 2, let us adjust, we'll be having 1 by 2a integral 0 to t sine of au plus at minus au, then plus sine of, it is au minus at plus au. So here this au term and au term will be getting cancelled. Here we'll be having au plus au as 2au minus at. That is equal to 1 by 2a integral 0 to t sine at plus sine of 2au minus at into du. Let us integrate this term. So it will be 1 by 2a. The integration of first term, the sine at is a constant with respect to u. When you integrate, you will be having u into sine at plus what is integration of sine term will be minus cos of 2au minus at divided by the coefficient of u will be 2a and the limit will be from 0 to t, which is equal to 1 by 2a. Substitute the limits. Upper limit will be t sine at minus cos of 2at minus at by 2a. Then when you apply the lower limit, minus, the first term will vanish out. The second term minus of minus plus cos of, it will be minus at divided by 2a. So this is equal to 1 by 2a into t sine at minus cos at by 2a, and we know that cos of minus theta will be plus cos theta, so this term will become plus cos at divided by 2a. So these two terms will be getting cancelled. So the final answer will be L inverse of s divided by s square plus a square the whole square is equal to, it is t sine at by 2a. So let me repeat the procedures here. The procedure for applying the convolution theorem for an inverse Laplace transform will be first break the product to a convoluted function, like L inverse of f of s into g of s will be converted to L inverse of f of s star L inverse of g of s. Then we use the elementary functions L inverse, and then we use the Convolution theorem formula integral 0 to t f of u into g of t minus u into du. Then we will integrate that term accordingly and we substitute the limits, and when we simplify we will be getting our desired solution. So thank you.